Salutations. I wanted to review my game that I made for my creative assignment for my class I-400. So this is a pretty cool game. It's very simple, but the concept of the game is essentially you're in a dream. And in this dream, what you're supposed to do is you are supposed to essentially try to find a way and enjoy it. Um, and hence the name, the corner of Stockholm and Adolescence. It gains inspiration from Stockholm Syndrome, where you fall in love with your captivity, and Adolescence, which is where I guess inspired loosely from Peter Pan and Neverland, where you never grow up. So you never grow up in this place because you're in a dream void, I guess. So I'm really excited to show you guys this. I want to show you some gameplay starting out. And I hope you don't mind. It's rather basic, but this is my first game, so I'm excited to have made this. So starting out, you'll notice that we're on this plane, and what's really cool about this plane is you can change your actually perspective, right? So I can go back to third. I like flying in third. First person is not very nice. And there's a somewhat realistic plane flight motion. You'll notice we have a pitch, yaw, and roll that we're controlling. Obviously, it's not the best flight engine, but I'm very proud of it. Next, you'll notice that we have a lot of these really cool trees with various values of heights. I can't claim credit for that one. That one actually comes from a package I was able to import. From there, you guys will probably notice that we went through the rings and we sped up greatly. And then next, you'll notice that there was a lot of rings around. These rings are actually procedurally generated. And what is also procedurally generated is the runway. Again, very basic procedural generation. I made those all myself. But the procedural generation follows some rules. It could be improved by maybe setting a requirement of hoops per quadrant, or average hoops per quadrant, and then maybe even setting a variety of heights. So there's an even split between the height groupings, and then there's also an even split between the other sectors. So you kind of divide it up into three-dimensional space and make sure that there's even distribution of all this. So I've talked about the game a lot. What I want to do now is I want to talk to you about the code. So starting out, we have our speedboost.cs, C#. So what the script is doing is, first of all, it is our control, and it also basically, no, this is what controls the ring, right? So for the rings that we saw in the sky, you'll notice that they sped up this plane. So we have what's known as a coroutine, speeding up the plane. And all this is doing is just boosting the max speed of the plane so it can go even faster for about 5 seconds. From there, also, it'll only trigger if an object is called a plane that goes through it. So if it spawns in a tree, trees aren't going to suddenly speed up, because that would cause an error since there is no variable called nitro max speed for that. From there, we also have something where the user movement will impact the color of the rings and how they are rendered, and we also assign a random starting color in our update. We update the value of the color based off change object from user movement, but we start out with a random color in our start function. And then we also ping pong or cycle the alpha value, so you kind of see it show up and then it disappears. Kind of a cool little effect. Okay, so from there, this is our procedure generation for the rings. What we do is we have create rings in the start. I'm going to call that a constructor. And then create rings is defined as something where we instantiate a prefab. I really like instantiation because of how it works with memory in the models. So it creates an exact copy of everything you've already defined, but you can change properties such as location and rotation. So that's what I do. I define a vector 3 position, and I define it to be a random value between the ranges of the map, and then from there I also define a random rotation where I only rotate the x a random degree. Okay, so next we have manage runway. So for manage runway, it's kind of the same structure. What's happening here, and we have create runway, which is called from the constructor the start function, and then the logic is pretty much the same, right? Except there's no rotation. We want the rotation to be exactly the same, so we do quaternion.identity, which I hope is intuitive. If it's not, and identity is just saying, like identity, property, and geometry, the thing is exactly the same. It's exactly the same as the parent, essentially. Okay, so from here, This is where we actually have our fly system. So this is based off a car script, so maybe that's why it's not the best flight system. But what's happening here is we have our movement, which controls us going forward, and our natural acceleration of the object. From there, we have basically this fly plane and this spin propeller. Spin propeller animates the propeller, fly plane controls how you move through the air, which we define lift, roll, and pitch. So we initialize these. From there, we get an input, which is just going to be a multiplier value. If it's the positive roll value, then you multiply by 1. If it's negative 1. If it's neither, then it's 0. And that's the same logic for all of these. And then we have the same multiplier for each one because that's how we want to have the plane be in effect. I think if you play with these values, / maybe assign some acceleration value to this, then you probably get something a bit more realistic. Okay, so next we have our rotation that's defined by our pitch, yaw, roll. And this is a vector 3, which may be a little curious to you, but it's because we're using this rigid body rotation value to multiply, right? So the reason we have this Euler angles is because it requires a vector 3 rather than a quaternion. Okay, and then finally we have our spin propeller. And this is really simple. It's just iterating through each object that we want to animate in a similar way. And from there, it is going to essentially just rotate them. It'll rotate it because it's the blade propeller. And then next we have our smooth camera. This is just a script that'll follow my object, and it'll also define the perspectives. And so what's happening here is we have basically a lerp that's being defined, a linear interpolation, which is going to say, okay, we have this point, get a point in between, and approach that, and just get a point in between these 2 points. From there, we have a rotation that gets set using our forward vector of your movement. We're saying car, could be anything really, could be plane. And then we also have a view direction, which is going to be a slurp. This is a play on linear interpolation. But we see here that we have our rotation vector, our view direction that we defined up here, which is the quaternion, and then we have our camera rotation speed times our frame speed. And so what this is basically our rotation to that angle, how quickly that happens. From there, we set our rotation to view direction, we set our position to camera position. And then I also have a method called change POV. And in change POV, when you press C, you will increment an index, cycling through an array, except you'll take a mod value of this. So modulus is a really sweet operator. It gets the remainder. And it's going to be modulus the length of your array. So this is a dynamic setting. And I also have this special case here where I increase the follow speed of your camera times 4 if you are in a first-person perspective. Otherwise, it's always going to be 10. And then finally, this is the mod operation. In C#, mod doesn't work the same as it does in other languages. So what you need to do if you want to get the remainder is you have to do a mod in, add in, and then you have to do mod that. Where did I get this formula? I got it from Stack Overflow. So thank you, whoever gave that. I probably should have gotten credits. But yeah, so that's all the code. So the last thing I'm going to do with all this knowledge that we've gained about this game is we're just going to enjoy the outro and hear a bit of a reflection on this. So I'm going to go up again and just notice all the features I mentioned. One thing I really liked about this project is it got me good experience with an engine, a game engine. Unity's, not as advanced as Unreal in some ways, but it still is very, very advanced. I really like the scripting. This project was extremely fun, and I was able to make an idea and implement it in a cool way. And it's just fun to kind of learn these controls. I'm glad I'm enjoying playing the game, because I feel like it's a good sign that you made a good game. What I really struggled with was, I think, the creative direction and story of this game. But I think, because I was building skills, that wasn't really the core thought process of my game. Obviously, if you were making a game for real, and by that I mean trying to market it and sell it, then what you would want to do is you want to start with the concept before you even got into coding, where I was just focused on the features and then I tried to piece together a concept. So I kind of had the order wrong. But anyways, thank you so much for watching. I hope you guys enjoyed this, and yeah, just please leave any comments, questions. I would love to talk about this, and thank you very much.